Okay, Assalamualaikum. And today we will do our PBL task 2 about water dispenser system. And I will introduce our group members. First is Muhammad Ashraf bin Basaruddin, matrix ID B0122100039. And myself is Muhammad Shamil bin Hamzah, B0122100191. And the next one is Muhammad Iqbal Hafiz bin Ismail, B0122100298. And the last one is Wan Irfan Wafi bin Wan Ni Arman, matrix ID B0122100298. And our lecturer's name is Dr. Tamizi bin Ahmad Izzuddin. Okay, for our PBL, we will do about water dispenser system. So, for this report, details the design and functionality of an assembly language program developed to control an LED and seven segment display based on temperature settings. Intent for use on a microcontroller or similar embedded system. The program utilizes input from switches to select between operational modes, startup sequence, cold, warm, and hot temperature displays. Each mode corresponds to specific visual feedback on the 7-segment display and updates to an LED indicator. The program uses conditional branching and software delays to enhance user interaction and understanding of the system operational states. The report examines memory mapping, operational flow, subroutine usage for timing, and detailed analysis of each temperature display mode, highlighting implementation and potential enhancements. This comprehensive examination demonstrates how assembly language can be effectively used in embedded system for temperature monitoring and display application. Okay, our objective for water dispenser system is to analyze and document an assembly language program designed for controlling an LED and 7-segment display based on temperature settings. First is provide a detailed understanding of how the assembly program interacts with hardware components such as switches, LEDs, and 7-segment displays. The second one is the explain the implementation of temperature displays, routines using conditional branching and bitwise operation to update visual feedback. The third one is evaluate the effectiveness of software delay routines in managing timing between display updates. The last one is discuss potential improvements or optimization for enhancing functionality, efficiency, or user interaction.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Irfan Wafi bin Wani Arman. My metric number is B0122100296. Okay. This is the benefit of the water dispenser system, which is have a three: the temperature control, user feedback, and efficiency and convenience. Okay, the first is temperature control. It is provide user with the option to dispense water at different temperature, which is cool, warm, and hot, catering to various needs such as drinking, cooking, or making beverage. Second is user feedback. The 7 segments display an LED indicator provide clear and immediate feedback on the current temperature setting and operational status, enhancing user experience and making the system easy to understand at a glance. The third is efficiency and convenience. The system allows users to quickly switch between different temperature settings, providing hot and cool water on demand without the need for additional appliances, and ensures ease of use with the simple switch-based control mechanism. Next, this is our flowchart. If you can see, the flowchart that control an LED display based on user input from 4 switch. This is a switch D1, D2, D3, D4. The flowchart refers to the switch as D1, D2, D3, and D4. As I said before, the system begins by checking the state of the switch D1. If D1 is pressed, a display startup sequence is initiated. After the display startup sequence, the LED display shows 50 degrees Celsius. If D2 is pressed, the LED display is updated and then shows 38 degrees Celsius. Likewise, pressing D3 update the display to show 98 degrees Celsius. Pressing D4 also update the LED display, but to what temperature is not shown in the flowchart. After each update, the system returns to the main loop, and which presumably continuously check to the state of the switch. Next, I give to the next presenter.
Okay, I'm gonna explain for the coding part. This EQ directive are used to define memory map input-output address for various components like switch LED and 7-segment display. The program start at memory location $1000. Register D0 to D4 are initialized with specific value. For the main loop part, the main loop of the program continuously check the state of the switch and update the LED and 7-segment display accordingly. Start up. In this state, the 7-segment display are initialized with specific value. For the cool part, this state indicate a cold temperature 15 degrees Celsius and update the display and LED accordingly. For the warm part, this state indicate a warm temperature 38 degrees Celsius and update the display and LED accordingly. For the hot condition, this state indicate a hot temperature 98 degrees Celsius and update the display and LED accordingly. Delay subroutine. This subroutine introduce delay by counting down from a specific value. The end directive mark the end of the program. Okay, result in simulation. Okay, for the first one is no level setting. We're gonna turn on for zero switch. Then the output gonna say no level from the coding. Okay, for the second one is level one. We're gonna turn on switch one, which is the cold state, 15 degrees Celsius. Okay, for the second state is a warm state. We're gonna turn on switch 2 to make the output on the display is 38 degrees Celsius. And the third state is a hot state. And we're gonna turn on switch 3 to make the output is 98 degrees Celsius. We're coding the display to make it into the number 98 degree, 38 degree, 50 degree. We need to put in hexa to make a seven segment display. Okay, I'm gonna pass to the next presenter.
Okay, Assalamualaikum and greetings to my lecturers and my fellow friends. My name is Muhammad HAFIZ bin Ismail. My metric number is B01221028. I will continue for discussion, conclusion, and recommendation. For discussion, the water dispenser system effectively demonstrates the use assembly language programming to control an LED and seven-segment display for temperature settings. The MC68K microcontroller manages hardware components efficiently, providing immediate visual feedback through clear LED and display updates for cold, warm, and hot water modes. The program's main loop continuously monitors switch input, directing to subroutines to handle different temperature modes. Software delay routines ensure accurate and stable display updates, maintaining system reliability and user trust. The design emphasizes modularity and simplicity, mapping key components to specific memory address for easy maintenance and scalability. The structure, this structure approach highlights the robustness of assembly language in embedded system, making it valuable tool for learning microcontroller, operations, and low-level programming. Next is conclusion and recommendation. Conclusion. In conclusion, the water dispenser system demonstrates effectively utilization and assembly language to control temperature settings through an LED and 7-segment display. The NC68K microcontroller efficiently manage hardware components, providing immediate visual feedback for cold, warm, and hot water modes. This system underscores the reliability and precision achievable with assembly language embedded system, highlighting its sustainability for real-time application. And for recommendation for future developments, enhancing error handling and expanding operational modes could further improve the system functionality and incorporating advanced user feedback mechanism on automation, software routines would enhance user interaction and system responsiveness, ensuring continued efficiency reliability in various testing. Okay, that's all for me. Thank you.